Hello, we are going to look at logarithm functions. In Math 161, this is section 5.4. Okay, so after you get familiar with exponential functions, the next step is going to be log functions because logs are the inverse of exponential functions. So it's going to be weird dealing with problems that have the word log in them. But the sooner you get comfortable with it just being the inverse of an exponential, it won't be so weird anymore. So the first thing we're going to get used to doing is going back and forth from the log form to the exponential form. And you're usually going to be more comfortable in the exponential form because we're used to it. But sometimes you're going to be stuck in a problem, and switching it to the log form will help you then solve it with your calculator. So it will be helpful to be able to go back and forth. So here's the pattern. If something is set up like this, it means the same thing as this. So you'll start getting used to where each thing goes. So the little number that's here goes here. The number that was over here becomes the exponent, and whatever was here goes there. Now, things to keep in mind is that we're always going to have a being a positive number. It's never going to be 1. And x always has to be positive also. So that is the most important thing about logs, is whatever goes here definitely cannot be a negative number or 0. And that'll become more important when we talk about domain. But for now, we're just going to practice going back and forth. So according to this pattern, this can be rewritten as 3 to the second power equaling 9. And going from log to exponent is also nice because sometimes you can just tell if it's true. Is 3 squared 9? Yes, so I can definitely tell I did that right. For number 2, there is no number in the little base part. So keep in mind that if there is nothing there, it's a 10. So the standard log is base 10. So this would be rewritten as 10 to the second power equaling 100. So all we're doing is practicing going back and forth. So the same way that log really means log base 10, ln is the same thing as having a log base e. They just gave it a special name. So when you see ln, you know that the little base that you don't see is really an e. So e to the third power would equal x plus 1 in this case. And then if we were solving, we could get the x by itself. Over here, starting with the little base, 3 to the x plus 1 power apparently equals 2x. So again, just practicing rewriting these problems. So now we're going to go the other way. If it starts in exponential form, if it were helpful, would you be able to rewrite it as a log problem? So just keep in mind that whatever is the base here becomes the little base for the log. And then whatever was on the other side goes with it. The exponent should now be all by itself. So it just takes a little practice remembering what goes where. So maybe pause and try the next two and then see if you get them right. The sooner you get more comfortable with this, the easier dealing with all these logs will be. Okay, some rules to keep in mind when you start seeing some of this happening in the middle of a problem is if you have the log of any type of base with the same number there raised to a power, basically all of this wipes out and you're left with just that power. So same thing with an ln and an e, because that's the same situation, because ln is really like log base e, right? So ln and e wipe out. And then same thing, even if it's written this way, b raised to the log base b, same thing, it all wipes out to just whatever is there. And then in this case, log of anything of a 1 is equal to 0. Because again, this is the same thing as saying something to the 0 power, right? And we know that that's always equal to 1. Okay, So just to keep those in mind when we go to solve some of the problems. Okay, if they're asking you anything about the domain of a log equation, the only thing to keep in mind is that you have to take the log of a positive number. So if I was doing something like number 1, that's just talking about the x minus 3. So if that has to be positive, I can set up something like that. And then this is easy to solve because I would just add 3. X has to be greater than 3. That is my domain. If they wanted me to write it as an interval, that would mean this, 3 to infinity. Okay, so number 2, same idea. The second I hear domain with log, I'm taking this part and saying it must be greater than 0. In this case, I would add the 9, but then multiply by 6. So x would need to be greater than 54. Those are 2 pretty simple examples. 3 and 4 are going to be a little more complicated, so we're going to have to remember what we just did in that last unit with inequalities. So when I say that x minus 9 over x needs to be greater than 0, this is the type of problem where I need to get everything on one side, which it is, set the top and the bottom equal to 0, and put those numbers on a number line, and then test each of my sections. So if I were to test something over here like -1, it would make the top negative and the bottom negative, which would be positive, which is what I want. If I plug in something like +1, I would get a negative on top, but a positive on the bottom. So that would be negative, which I don't want. And then over here, something like 10. 10 minus 9 would be +1 over 10, so positive over positive. So my domain would be -infinity to 0 and 9 to infinity. So this is just remembering what we did last unit. Same thing here. X squared minus 9 needing to be greater than 0. This is not as easy as 1 and 2 because I have an x squared. So I still need to think factor, which I can because it's a difference of squares. Set each of these equal to 0 and put them on the number line. So that would be -3 and +3 and test each section. So testing -4 would give me a negative and a negative, so that works. Testing something like 0 would give me +3 and -3, so negative. Testing something like 4 would give me a positive and a positive. So my domain would be -infinity to -3 and 3 to infinity. Okay, so if this is the part that was tricky for you, you can go back and look at solving inequalities with higher powers, or solving quadratic inequalities would help you with that part. Okay, but for the graphs, keep in mind that, like I said in the beginning, that logs are just the inverse of exponentials. So same things with the graphs. So remember, inverses mean that one graph has been flipped over the line y equals x. And so that means all of the x's and the y's get switched. So when I'm trying to graph something like this, log base 2 of x, it is hard to think that through. It's hard to do it on a graph or even like plug things in because the logs are weird. So I first think of the exponential equation. So since it was log base 2, I would think of 2 to the x, because this one makes a lot more sense. So remembering this one would have a horizontal asymptote at y equals 0. And if I plugged in -1, I would get 1/2. If I plugged in 0, I would get 1. And if I plugged in 1, I would get 2. So we remember this, right? So -1, 1/2, 0, 1, 1, 2. It would look something like this, right? So just to remember that. So now we're just going to switch all x's and y's. So instead of having a horizontal asymptote, we're going to have a vertical asymptote at x equals 0. So that's the first step. And then all of my x's and y's that I did here are now going to switch And so if I plot these carefully, 1/2 -1 would be here, 1, 0 would be here, 2, 1 would be here, and that's my asymptote. So I'm not going to cross it. So the log graphs look something like this, which mean going up and down is not really going to affect the asymptote. It's going to be when we move left or right that will affect this asymptote. Just like last time it was up and down that changed our asymptote, this time left and right. So if I was told to graph this, I'm first going to think about 2 to the x. So we just did that, so easy. I'm now going to think about the log with base 2 and the fact that it's just flipped all the x's and y's. And so now what would I have to do to this to deal with these transformations? Well, the +3 inside, I'm going to do the opposite. And the +2 outside just affects the y. So using these points that I just found, I'm going to subtract 3 to all of the x's and add 2 to all of the y's. So 1/2 -3 would be -2.5. 1 minus 3 is -2. 2 minus 3 is -1. Now for the y's. -1 plus 2, 0 plus 2, 1 plus 2. And we know that since our asymptote is usually x equals 0, but I've subtracted 3 to all of my x's, that's going to also affect my asymptote. So our asymptote is now x equals -3 because it also moved left 3. So -2.5, 1 would be up here. -2, 2, and -1, 3. So starting at the asymptote, it would be something like this. So remember, anything that happens inside the function affects the x, and we do it the opposite way. Anything outside the function will affect the y, but we keep it the same. So the more you do these, you won't always have to do this step. You'll be able to go right to the log step. But it helps when you're getting started with logs to always think in terms of the exponential first, because that one always makes more sense. And then switch x's and y's, and then apply any transformations that you need. So hopefully that helped. Let me know if you need any more help.